Good morning, students. In this session, we are going to discuss about what is process control block. In the previous session, we have seen what are process concepts and what is scheduling and what are the different states of a process. So here we'll see what is process control block in the session. Myself, Dr. Shirisha, Associate Professor from CSC Department, MLR Institute of Technology. Process control block looks like something like this, where it stores the entire metadata of a particular process. If you are taking any one process, this process will have all this data. Therefore, we are calling all this as a metadata. When your process has to execute, so all this metadata is maintained by one particular table, and that we are calling it as a process control block or a task control block, which consists of process states, which we have discussed in the previous session, and secondly process number, PID we can say. Third one is a program counter, PC. Fourth is where the data is stored. So simply we store it in the registers. Memory limits, from where what is the offset and what is the limit, and list of open files. So what is the date, what is the time, who is the owner, when was it protected or not, when it is modified. So all such information is also stored in the form of a process control block. So information associated with each process we call either as a process control block or a task control block. If it is a batch process, we are calling it as a batch, right? Job, right? Batch process, so we are calling it as a job. That may be a task control block also. So process state. So what are the different states we have? Running, waiting, ready, okay, new state, exit or terminate state, like that. And program counter is the location of the instruction to next execute, which stores the information of the process that needs to execute the next instruction. And the CPU register, contents of all process centric registers. So where you store you store the data, a small amount of data, we can use registers. So contents of all the process centric registers can be stored in the form of registers. CPU scheduling information, priorities, scheduling queue pointers. So CPU scheduling information means what? You have several scheduling algorithms, not only priorities, you also have FCFS, you also have SJF, you also have round robin and priority, multi-level feedback queue, and etc. etc. So this scheduling algorithms we'll be discussing in the coming sessions. Okay. Then after all four, we have as a memory management information. So memory management we'll be discussing in the third unit, and where memory can be allocated and in what way it can be allocated. There are different types. So that is memory management. Then accounting information, where CPU is used and what is the clock time elapsed since the start, what is the time limit. So all that accounting information, when it is modified, protection, okay, access controls, everything come into the picture. Then IO status information is where it gives the information about the IO devices that are allocated to process, like list of open files, etc. So these are the few informations or metadata I can say for every process that goes into the execution. This diagram shows you how a CPU switches from process to process. You have different process here. When you have different process, each and every process will be saving its own process control block. Therefore, process P0 will be having a PCB0, process P1 may have PCB1. So, this is a process control block of P1, this is a process control block of P0. So, you have P0 and P1 process and the operating system you have. So, when P0 is executing, when this is executing, so it is after a particular time period, save the state into PCB0. And here the process P1 is idle because this is executing, and reload state from PCB1. So here the execution of PCB is getting started, and therefore it changes the state from idle state to running state it changes, and here after running it terminates, and here or throughout it is idle. When it is idle, it is the P1 is going into the execution. Now all the state information should be maintained both in PCB node and PCB1 also with respect to P node and P1 processes. So when you get an interrupt or a system call, your execution is again halted or preempted, and this again saves the state into the PCB1, and therefore it becomes idle. Now any other process can execute here. After particular time, again P naught is trying to execute. When P naught is trying to execute, again you are reloading the state into the PCB node, its own process control block. Like that, whenever you execute, process control block captures that information and loads and saves that information into the PCB. So this is where you have this picture where it shows a complete overview of how the switching is happening between the processes. Then process scheduling. Coming to process scheduling, you know what is process now and what are the different states now, but how to schedule. So what is bean scheduling? Who will schedule? And who will load the process into the processor? So all these questions arises. When all these questions are arised, so maximum CPU use quickly switch process on CPU for time sharing, because when you have multiple processes, if P1 is executing and P1 wants got an interrupt and wants to wait for particular input output, then what happens is CPU is wasting its time. So the time can be shared to the other process so that P1 or P2 can execute its process. So in that way, what is happening? The data is being shared, the time is shared between the process, so that CPU is always busy with either of the process, any of the process which is been executing. So in that way, we are increasing the performance and efficiency of a processor. So process scheduler selects among available process for next CPU on the execution. This is like a program counter where it schedules the next process that has to be scheduled. Even if the interrupt is occurred, even if the event is occurred, the process scheduler should be ready always by knowing the entire information, and it sends the process to the processes. So maintains the scheduling queues of the processes. So what are the scheduling queues? There are three types of queues. One is a job queue, second one is a ready queue, and third one is a device queue. What is a job queue? It sets all the process in the system. Means whenever you have n number of processes, so this is a job queue, P1, P2, P3, P4, so on. How many processes you have? Those are all the processes are set. Okay, that is a job queue. Now set of all processes residing in the main memory, ready and waiting to execute, that we are calling as a ready queue. Now P1 will be ready for execution, but P2, P3, P4, they are in the job queue because they are waiting for their turn. So when they will get their turn, when P1 is executed, then P2 may get the turn. So in that way, it is changing from job queue to the ready queue. Then device queues. Set of process waiting for an IO device is nothing but a device queue. Then process migrate among various queues. You have job queue, ready queue and device queue. So process either at times it may be in the job queue, it either may be in the device queue, or it may either be in the ready queue. So whenever it is in the ready queue, then only the scheduler, what it does, we call it as a dispatcher. It dispatches, the scheduler dispatches it to the processor so that the process can undergo its execution and complete its job. So this is about the process scheduling. And we have one diagram here which depicts about the ready queue and various IO device queues. Ready queue and various IO device queue. So here is what ready queue. So ready queue is having a queue header here and tail. Head, tail, like this is a secondary storage device like magnetic tape, magnetic wave disk, terminal. These are all about, we are talking about different devices and they are ready queues. Now various IO device queues. So here whenever you have something processes there in the ready queue, it should undergo its process control block. So what is process control block? It stores in data in the form of registers, it's a stack, it's opening files, etc. Whatever we have seen in the PCB, the entire information will be seen here in the process control block. So like that, everything, every process will undergo its PCB. Now this chain is showing you what it is linked. So one PCB is linked to the other PCB here. So this is how the ready queues are being all related, and it shows the complete information with respect to the process control block. Now this is a queuing diagram we call. Queuing diagram is whenever you have a ready queue, it is ready, then it goes allocate the CPU for its execution. But if you have any IO request, again it goes to the IO queue, and whenever you get a IO, again it will go back to the ready queue. This is the first scenario. And whenever the time slice expires, directly it is again going back to the ready queue, and then it is going back to, this is only time slice expired. Your process have not completed its job. That means what? If you have a online exam, okay, when you have an online exam, you have 1 hour for your exam to get completed, but at the last minute you're completed throughout 1 hour, but your exam is not completed. Once the time period is set to 0, the timer is set to 0, immediately you will logged out. Either you complete your exam or you are not completed. What is happening there? Your time slice has been expired, so you are out of the exam. So in that way, this is the second scenario. When the time is expired, again it will go back to the ready queue. Okay. Next, fork a child. Fork a child is creating a child process. Creating a child process. Fork, we call it as a Linux system call. When you use a fork system call in the Linux operating system, then it creates the child process. So child executes and it go to the ready state followed by the CPU processor. And this is the third case. Then fourth case, waiting for an interrupt. Waiting for IO or waiting for interrupt, both are similar. So here when interrupt occurs, it will again go back to the ready state. So these are the 4 stages where we can see that this as a queuing diagram. When does a process will undergo execution, that means directly to the ready state, to the running state and processor. But from there, without completion, when it comes back. So these are the 4 scenarios where the process can come back when it has a IO request, when it has an interrupt, when it has an event to occur, a time slice is occurring, and whenever a child process is getting created. Okay. So this is called a queuing diagram. Hope you all understood what is a process scheduling, and we have seen what are different process states in the previous session, and this is where we have discussed the process control block, its queuing diagram, and how the process from the ready queue takes the process control block information, and states will vary from one state to other state in a timely manner. So this is and finally the queuing diagram of a process. Hope you all understood. Thank you all.